time to start the recording and make this happen officially. So hello, folks. We're talking plants. We're talking homework. It's almost April, and it's still, oh, it is 50 degrees outside, but with a very fierce wind. Springtime in Iowa. Let's see. I'm going to open up the class website so I don't forget to remind you of things that are going on. Put that over on this window, and I will get the screen share going for the Zoomers as well. Always helpful to not forget that part. So just a little bit ago, I sent you an email with a link to Lecture 5, which I just finished this morning. And the rest of my material is close to being done for 5A. For 5B, I haven't started yet. So I'm going to have to decide what of this I can present within the remaining time allotted, and then otherwise direct you to other resources or record offline videos for things that I want to cover, but we're not going to have time to do in class. But what you can be working on right now is homework 3, which is an online homework based on 4A. Sorry, that's a typo. I think that was from a previous numbering system, as well as you're preparing for your presentations. So how are those going? How's presentations coming along? Situated? Okay, yeah, you're going first, so yeah, you're going to start it off.
Lisa, I had a question.
Yeah.
So I ran M+, and it's saying that I need to specify starts equals.
Okay.
What is that doing?
That is an odd request of it. What that is doing is checking for local maxima and the maximum likelihood aspect of the solution. So that tends to be a concern when you're doing something with a mixture model, where basically your model can think that it's converged onto the most likely estimates, but it's really like just stuck on a relatively higher spot that's not the maximum. And so starting the model at different places in terms of start values can help you figure out if it comes to the same convergence point every time, and if it doesn't, then that's a problem. But I'm not sure why it would tell you that for your type of model, though, which is just it's a multivariate growth model, right? The one you showed me yesterday?
There's no mixture.
There's no mixture.
Maybe I'll take it off and see what happens, but yeah, it was requesting it.
It goes in the analysis section, and it would be like starts equals 10, or something very close to that.
Starts equals 20 is, I think, what it recommended.
Okay.
I have no idea.
Okay. Well, then once you run it, it will take longer, but then in part of the output, it'll tell you, like for each of the 20, like what the most likely, what the convergence aspects were, and whether it matches, and that's the key. If it matches, you're in good shape.
Okay.
Other questions? Anything I can help with? All right, well, email and office hours. Otherwise, don't be strangers. I knew what I was signing up for when I assigned projects. I knew what that was going to entail for all of us. So we're going to get through it. No, don't give me that face. I'm just saying, like, I'm committing to helping you. Like, I'm committed to having, 16 different projects in my head for the next month as I work, back and forth with everyone on what they're doing, and that's what I've committed to. What I've also committed to is teaching you how to do multi-level mediation. How about that? How about that for a segue? So we were in example 4B last time. Do you remember the story with this? Maybe? We have 3 variables that were collected daily for 5 days in a sample of older adults. So this is a setting in which, although these variables are longitudinal, they don't show individual differences in change. So people just fluctuate in the extent to which they're grumpy on a given day, the extent to which they feel worse on a given day. There are between-person differences in both of those things. We also ask them whether or not they had a stressor happen on each day, and we have the person mean of that variable as the between-person indicator for that construct. So given that each variable is measured every day, we have the potential for mediation at the between-person level among the intercepts or person means, as well as at the within-person level among the within-person residuals or the level 1 variable as an observed predictor here. So we did, I think, steps 1 and 2 last time. So step 1, let me go back to the picture, is to examine how does stress relate to negative mood without anything else in the model other than the covariates of gender and age that we had included there. And we do that so that we can test whether or not it even makes sense to think about mediation. So as a prerequisite, you do need to have this x to m path for at least one level be significant. Otherwise, there's no logical possibility for mediation. You do not have to have x to y be significant, though, because what mediation means is that the path from x to y is different after you control for the mediator than if you don't control. Different can be significant to not to significant, positive to negative, positive to less positive. It can be anything. Different is all that's required. But the x to m part has to be there for this to make sense. So we did the x to m, and then we also did, I believe, the m to y. Did we do that? Or we do x to, now I'm forgetting what we did. We did x to y first. That's what we did, I think. Yes. Now I'm remembering. X to y first. X to m is a thing that we definitely need to have. But in order to describe how the effect from x to y changes before versus after the mediator, I want to know what it is before separately. Then we did negative mood to physical symptoms, m to y, and that was our first example of a multivariate model. So now we're ready for step 3, right? Fitting the whole enchilada? Exciting stuff, huh? Note that I have 7-Up today. I've already hit my allocation of caffeine, so you're seeing me at the top of the curve here. So we have everything in the model at the same time here. Step 3, let me move my monitor so I'm not turning my head so much. So what's going into the model then in terms of using variables? Symptoms is my y, women and age are my level 2 time invariant predictors. So they can only go in the between model. I have mood as my time varying mediator, and note that it is centered at 2, so that because it's still a predictor. So I want to make sure that any fixed intercepts of outcomes have a meaningful, they're meaningful given the 0 value of the predictor, so I'm still subtracting a constant to ensure that that happened. Stress is a binary variable of 0 or 1 for every day. I already made person mean stress to put in the data set because I'm treating the X part via observed predictors instead of latent. And then I have made an interaction term, which is somewhere in here. Oh, it's in the define section here. So shortcutting the code a little bit so that it makes it easier to keep track of what's changed. So within, I have observed time varying stress there because I'm not asking the model to carve up the variance in stress. I did it basically myself by having my binary level 1 predictor and then having person mean stress as a between level predictor at level 2. But the outcomes that I'm letting it carve up, which is time varying mood and time varying symptoms, are not on the within or between lines. That's how it knows I want them to be carved up into both. So now I have, for the variables that are being predicted first, let me make this bigger so we can see it all. Symptoms is my y, mood is my mediator, and by referring to those, that's their residual variances. So these are going to be variance left over at level 1. Here are my 3 level 1 slopes. So I'm using what I call placeholder notation because each of these could potentially become random, and each of these could potentially have cross-level interactions. So I've labeled them in a way that makes sense to me, not based on the variable names, but based on their role in the model. So I've got within person x to m, x to y, and m to y. That means that this fixed slope and any slope variance around it that I were to estimate go in the between model instead. So the first 4 here in brackets are either means or intercepts, given that both mood and symptoms are being predicted. Those refer to their intercepts. So that's a level 2 parameter in this way of notating things. Just like if we were to write the equation, the fixed effects always go in the level 2 model, and it's always placeholders in the level 1 model. It's literally the same structure here. So you can think of this like the equations. The word for the variable here refers to its level 2 variance left over, what I would call random intercept variance left over in symptoms and in mood. And then we get into, in the brackets here, and the corresponding labels, those are your fixed level 1 slopes. So they go up here, and I have labeled them so that I can use them in doing math or making constraints. And then the at 0 here, what does that mean? What am I shutting off by saying make it 0? The random slopes that go with them. Why did I do that? We don't want them today, because this was hard enough is the answer. This is enough. But this is a testable hypothesis. Do you think that the extent to which having a stressor makes you grumpier than usual varies across people? Could. Does the extent to which having a stressor make you feel worse than usual? Could that vary across people? Sure, it could. The extent to which being grumpier than usual makes you feel sicker than usual, could that vary across people? Sure, it could. So if I had estimated any of these random slope variances, what I would also need to write are any covariances or direct slopes involving those variables. Those are not defaults in this framework. You have to add them yourself. Okay, with me so far? Then down here are the effects of my covariates on the mediator and on Y. So symptoms is Y, mood is the mediator. So I have controlled for gender, age, and their interaction. And then I have these things right here. These are the corresponding level 2 slopes among my X, M, and Y. But because of the way that I've estimated this model using maximum likelihood and placeholder notation, these are all contextual effects. So I have the effect of stress on mood as X to M. X to Y is stress on symptoms, and then M to Y is mood on symptoms. Almost done with the code. Not quite. Then we get to model constraint. So model constraint is a great tool because you can do a lot of things with it. Like the name implies, you can put constraints. So for instance, I've been helping a colleague troubleshoot very complicated models in M+, where the covariances between her random effects kept wanting to go out of bounds. So what I did is write a model constraint that says, hey, can you compute a correlation instead, and can you make sure that correlation does not go above 0.99? Thanks. So I did that, and it helped it come together. So you can sort of put lids or blocks on parameters that are going out of bounds. But you can also do it to make it do math. So in programs like SAS Estimate, Stata, LinCom, GLHT, or Contest 1D, you can do linear combinations of things that are added together or subtracted. But you can't do linear combinations of, say, variance components, and you can't do multiplicative combinations. But you can in here. You can do anything you want. So the first thing that I did was compute the level 2 between effects for each of my 3 mediation pathways, which is the within plus contextual gets me to between. So do you remember the difference between contextual and between? Do we need to go over that again?
Is contextual conditional on time equals 1 and between is between occasions?
It's contextual is conditional, but it's not conditional on time per se. It's conditional on the value of the level 1 predictor at that occasion. So for instance, if I go from stress to mood, the contextual effect is the incremental contribution of person mean stress after controlling for the effect of whether I had a stressor today. So like after I control for the level 1 relationship, what is the extra level 2 relationship? What is the incremental effect of being a person who tends to have a lot of stressors after I control for the fact that I had one or not today? So between then is not controlling. It's just what is the effect of being a person who has more stressors than other people? The end. So it's up to you which one you prefer. I greatly prefer between because it's easier to talk about. So that's the first thing I did, was build myself the between effects that I wished I would have had. Then I built myself the corresponding indirect effects at the within level, the contextual indirect effects, and the between indirect effects. So I am literally multiplying the slope from x to m at the within level times the slope of m to y at the within level to make my indirect effect. Doing the same thing for the contextual effect and the same thing for the between effect. So now I've got my whole multi-level mediation story. There are options, which is the note here about this. Model indirect does the math for you. It will compute indirect, direct, and total effects. It doesn't work for multi-level models, so you have to do it yourself. So whenever I do mediation examples in class, I almost always just write it out, because this approach of literally multiplying yourself works no matter what kind of model you have. This is the thing, by the way, that the p-values that come out of these are a little bit suspect, because they assume that the sampling distribution of these multiplicative indirect effects is normal, just like it would be for any other slope, and it's not. If you take the product of two normally distributed variables, it's not normal. That's what they're referring to. So a lot of research has gone into what is the right way to test indirect effects, and some sort of bootstrappy confidence interval thing is usually what people like. That's not available in multi-level models either, but you can take your output and go to Chris Preacher's website and plug those in, and you can get a bootstrap estimate from the solution, not the data. So if your reviewer 3 is concerned about your p-values, here's the more righter way to do it. Okay, here's all I get for model fit. So even though I'm working in a multi-level structural equation modeling software framework, I don't get things like CFI, model fit, RMSEA. I don't get that stuff, because you don't have that in MSEM in most cases. You certainly will not have it if you estimate any kind of random slope or cross-level interaction, because then you can't summarize your data with a single covariance matrix that holds for everybody. So this is all we get. All right, any questions on the setup, rationale, code, etc.? No, quiet, everyone's quiet today. Either that or this is just so crystal clear that there's no room for misinterpretation. Yeah, said no one ever. This shit is hard. All right, so the columns here are estimate, standard error. This is my Wald test. Usually call it a Z because there's no degrees of freedom in the story here, and the last column is the p-value. So within level, what are these two things? One for symptoms, one for mood.
Leftover level 1 residual variance.
Exactly, leftover level 1 residual variance, and it's leftover because these are things that are predicted. Otherwise, it would just be the full amount of level 1 residual variance. Everything else is at the between level. So let's do a little interaction practice, shall we? One of my favorite things. So who has more symptoms, women or men? This variable,
Men.
well, this variable is coded 0 is men, 1 is women, by the way. Yeah, men have more because the slope is negative. But is this the gender difference in all people or conditional?
Conditional.
Conditional. This is amongst 80-year-olds specifically. What happens to that gender difference as people are older, or in older people, I should say? This is a cross-sectional effect.
Gets more negative.
More negative. Would I call that stronger or weaker?
Stronger.
Stronger. Yes, more negative or more positive is stronger. What doesn't kill you makes you stronger. That whole thing. All right, now that one. This is the level 2 contextual effect of person mean stress on symptoms. What
And
is
is that
number?
centered at 40?
It's centered at 0.4 because
0.4, okay.
it's proportion of the days in which you had a stressor. centered at 0.4, which corresponds to 2 days out of 5. That's why. It's a slope. Anyone want to try? No one wants to try. Do you want me to do it?
Okay, so it's 2 days out of 5. That's throwing me off a little bit, but
That's just the centering constant. That does not need to be in your sentence.
okay, so this is between person.
It's contextual, but yes, it's level 2.
So for every extra day, am I on the right track or no?
Let's start with one unit higher. Let's just do generic.
Okay, so for every 1 unit higher in PM in the centered stress, this thing, symptoms go up by 1.091.
There you go.
And during what value is this contextual effect related to?
Average day for an 80-year-old man?
Right idea, but it's not conditional on age because we don't have an interaction of age and stress in the model.
Yeah.
So this is for every unit higher person mean stress. You can think of it as mean symptoms because this is level 2, goes up by 1. Now I got to make it contextual. After controlling for whether or not you had a stressor that day and its effect on symptoms at level 1. So this is incremental. If you tend to have a lot of stressors, does that sort of carry over on the rest of the days? And now the unit part, the range of this variable, because this is a proportion of days in which you had a stressor, the range is 0 to 1. So a unit is the entire length span of the variable. A unit is the difference between people who had no stressor days and all stressor days. So we talked about last time that you are allowed to move this coefficient around to make it interpretable. You are allowed. So one thing you can do is divide this by 10, move the decimal over, and you could say for every 10% more, then mean symptoms goes up by 0.1. Vladimir had the idea of dividing it by 5 so that you could say for every additional day in which you have a stressor, it goes up by 0.2-ish. I like that one too. You're allowed to do that. Question from the Zoomers. Conditional on how much stress was experienced on the same day, people experience stress has 1.09 more symptoms than people who don't. Is that right? Yes, it is. After controlling for the effect of today's stressor, whether you had one or not, on symptoms, this is the extra incremental level 2 contextual effect of being a person who tends to have more stressors than other people. Lots of words. So, stress makes you grumpier. People who have more stress are grumpier than people who have less stress. Let's put it that way. This is a between-person cross-sectional. This is something that we could have examined in a cross-sectional study, right? These are differences between people. Mood is the next one. That is, so this was X to Y. Mood, this is M to Y. So for every unit higher, and this is not person mean mood, this is like latent intercept mood. So this is, I think, the first time we've seen this semester where this is an outcome in the model predicting another outcome in the model. This is referring to the random intercept being estimated for mood at level 2 as the predictor. So for every unit higher random intercept in negative mood, mean symptoms goes up by 1.8 after controlling for your current level of mood and its effect on your current symptoms. So I would need to know what the scale of this variable is to have a sense of what a unit is. And fortunately, that's in my model as well. So residual variance down below here with mood, that is the variance of my level 2 random intercept for mood that is left over after being predicted by stress. So I'd have to, if I wanted to know what its original variance was, I'd have to turn everything into covariances so that it's all the variance, not just the leftover variance. but that gives me a sense of what the scale is. So this is a latent variable as a predictor. It is a random intercept at level 2. And it is carrying a contextual effect because of the way that we set up the model. So far what we know is X to Y is significant in terms of contextual effects. M to Y is significant. Now the missing piece is X to mood. Wah, wah. So logically speaking, we can't really argue for mediation if the first link in the chain isn't broken. Is broken, I should say. But we can talk about it still in terms of whether the indirect effect is significant. It's up to you whether you want to call that mediation or not. Okay, so we did this much. We can do this block. Now we are predicting the random intercept for negative mood as the mediator, and we're doing it from all observed variables. So person mean stress, for every unit more stress than other people, negative mood goes up on average by 0.124 after controlling for the effect of current stress on current mood. And it looks like there's no gender difference in 80-year-olds, there's no age effect, and there's no interaction on mood. I put those in there so that the same things would be controlled for with respect to everything that's being predicted. Then we get to this block here. What are these things that are labeled as means, even though they're kind of not?
Are those interaction effects? No.
Not in this model. They could be, but they're not.
Within person, random, are they random intercepts?
Closer. What did you say? These are actually the level 1 slopes. Now, why they're labeled as mean is from the estimation perspective. When you make these placeholder variables in the syntax, M+ is thinking of them as a new latent variable in the model. The mean of the latent variable is always a fixed effect. The variance of the latent variable is always a random effect variance. So from that perspective, that's why they're labeled as means, is because they're the means of this latent variable. But what the latent variable is a slope. I know. As I said before, this shit is hard.
In terms of output, so we didn't have any cross-level interactions here in this model.
I don't believe so.
And we didn't, and we specified the random variance around these level 1 effects at 0.
Correct.
So we could, I mean, I don't know if this is right, we could have specified these effects without the placeholder syntax in the within part of the model,
Yes.
and gotten the same output, but would it have set the means or intercepts?
So the question was twofold. Did I have to use this placeholder notation given that these are not variables that have variances and they're not being predicted via cross-level interactions? And the answer to that is no, I did not have to do it this way. I could have just taken the placeholder part off and just written it directly like that. And if I did that, two things would happen. Number one is that the level 2 effects become between instead of contextual, if I'm using maximum likelihood. And number two is that in the output, these slopes would show up under the within model directly. So they move and then they look like slopes again, not means of latent variables that are slopes. Yeah, that's the weird disconnect here, is that this latent variable itself is a slope. So a slope can have a mean and a slope can have a variance. We call the slope mean the fixed effect, and we call the variance the random slope variance. I did it this way so that if you wanted to add random effects and cross-level interactions, you could.
Now they would have been labeled as means in the within part of the model, or what would they have been?
They would just be slopes in the same way that it would be y on x. It would just look like that in terms of structure. If I were to add cross-level interactions, for these things, like these would be predicted by something else. Like, let's say I wanted to know if the level 1 relationships varied by gender, something like that, then these would now get moved down to intercepts, because it's the intercept of the factor after it's been predicted, but it's still a slope, not an intercept or a mean. I might have an example where that happens next. I'm thinking maybe I did something like that, but I don't remember exactly what I did. So we're going to find out.
I'm pretty sure it's in there.
Okay. So here's the problem. Like, for every one of these handouts, there's probably 6 different versions where I've tweaked something or added something or taken something away. And so it's like, we're going to be surprised by which one this is. Okay, so within persons then, on average, X to M is significant. So after controlling for your negative mood, if you have a stressor that day, your physical symptoms that day are higher by 0.16 within persons. So a stressor leads to relatively more physical symptoms than usual, and that is significant. The other 2 relationships of, actually, nope, damn it, this is X to M. I'm talking about X to Y. This is stress to mood. So yes, if you have a stressor, it pisses you off more than usual. How about that? Even when you're retired, which is all these folks from the sample live in a nursing home. X to Y, though, is not significant. So after controlling for the effect of negative mood, there is no direct relationship between stressors and symptoms within persons. And M to Y, also not significant. There is no relationship between mood and symptoms after controlling for daily stress. What are these 2 things? Labeled intercepts, and that's actually accurate. This is the fixed intercept for symptoms, which we're used to seeing. And what we're not used to seeing is the fixed intercept for mood, because it is both the predictor and an outcome. So this is the expected value of mood when everything predicting it is 0 at level 2. The reason that it is close to 0 is because I subtracted 2 to make it that way. Otherwise, the fixed intercept for symptoms would be for somebody who has an average mood of 0, but the scale of this variable doesn't have 0 in it, so that would be weird. So I subtracted 2 because it was a 1 to 5 scale, so that was sort of near the mean, which was on the low end. So the symptoms intercept then is for like somebody who tends to have a 2 on most days. That's the way I would think about that. Yes?
It's also conditional, is it conditional on men that are 8 years old?
Yep. Yep, everything. So the intercepts are conditional on all the stuff that predicts each one being 0. So the same rules apply in terms of how you set up your predictors. 0 needs to be within the scale for it to make sense. Almost done. What are these things in the between model called residual variances, which is close but not quite what I would call it? What does M plus mean by residual? Starts with an L.
Leftover?
Leftover, yes, that's what I would call it. Yep. So this is, and the fact that it's leftover variance at level 2 means what would I call these things usually? These are random intercept variances. They are random intercept variances left over after being predicted by age, gender, their interaction, and anything else. Yep.
So does that mean like we still have more to go in terms of understanding the differences between people?
Yep.
Symptoms and mood?
Yep. Some people are still higher than others in these variables, and we don't know why.
And it has more to do than just sex and age and average stress.
That's right. Exactly right. Yep. More to do with it than the things we have in the model currently. Last but not least, new additional parameters. These are the between effects that I got from adding the within and contextual for each kind. And then the indirect effects. It looks like there's no significant indirect effect at level 1. There is no significant contextual indirect effect, but there is a significant between indirect effect. So this is a nuance that would be difficult to explain, I think, like what the difference in conclusion would be here. But the way that I would say it is that the relationship at level 2 goes away after you control for level 1. That's probably the easiest way that I would say it. Some would argue that even though this p-value is significant, this doesn't make any sense because of the fact that the relationships weren't significant, but those were the contextual. We have the betweens, they were, right? That was right above here. Oh, I lost it. Yeah, the betweens are, so. All 3 between slopes are significant, which is then unsurprising why the combination of x to m times m to y was also significant. And these are the p-values that someone's going to yell at you if you look at them. But I'm going to go out on a limb and say that if it's significant here, if you bootstrap confidence interval bit, whatever, it's probably still going to be significant. So, whatever. Okay, how are we doing? Let's see what's next. More code. Oh, trying to demonstrate how to do latent variable interactions. So let me go back to my picture for a minute as motivation for why this is a thing. So if I wanted to look at, say, the relationship between person mean stressors and gender and whether this slope differed by gender, I could do that, right? I would put gender in the model as an interaction with person mean stressors, and that would basically be another box, and I would have a slope from that new box to my circle. No problem. I would have to make the interaction term myself because it would be an observed level 2 predictor times another observed level 2 predictor, but that's okay. What I'm talking about would be, what if I wanted to look at gender differences in this slope from a circle to a circle? How do you make an interaction term out of a circle and a box? Not with math, right? We don't do that ourselves. This idea of making what's known as a latent variable interaction has a very long history in the world of SEM. A lot of different people have tried to figure out ways to do it. I think the current best practice, so to speak, is to let it happen under the hood within the estimation process. It requires numeric integration, so you have to add a couple different options to your estimation, and it can take a lot longer. But you can end up with a latent variable interaction in your model that is unobserved in the same way that your latent variable was unobserved. So I tried to do this. Here it is. And the first thing that happened is that M+ yelled at me. And it wouldn't run it. And I was like, why is that? So I tried to estimate an interaction, and it said, no, it's observed interaction because it kept interpreting it as the original mood predictor and not the random intercept part. So I did a workaround by essentially taking my mood random intercept, moving its information to a new latent variable and renaming it so that it was detached from the original variable, and then M+ would work. So I had to add algorithm equals integration to the analysis to be able to do this. But here is my weird workaround here. So what has changed in order to look at moderation is this thing right here, this section right here. This is foreshadowing what's going to happen with the world of structured residuals in the next set of stuff. So I am defining a new latent variable called mood int by my random intercept at 1. I am then shutting off the original variable's intercept, fixed intercept, and variance, and estimating it for the new variable instead. So this is just a trick. This is not doing anything in terms of changing the model. I am taking the information in the level 2 intercept that it estimated, moving it to a new variable, and then estimating all the relationships with the new variable so that it didn't get confused as to, did I want it at level 1 or level 2? This is the kind of stuff, by the way, that you find on the M+ discussion boards when things don't work. Like they know how to like hack their own program. So this is probably Linda Mutaine's suggestion that I'm pulling this from. So now mood int is the variable that represents my level 2 random intercept variance in my mediator everywhere down below. So I swapped that out. And here is the new moderation terms. So yes, this is why I did it this way. He knew what was coming, even if I didn't. So now within person M to Y on women. Picture multi-level equations where you have like beta 1 equals your fixed slope plus some variable. Like that's what this represents. So the within person slope itself is being predicted by gender. That is a cross-level interaction between a level 1 relationship between mood and symptoms with a level 2 predictor. So that is allowing moderation of the within-person effect of mood on symptoms to allow moderation of the between or contextual effect of mood on symptoms. Then that's this new thing right here. X width is the key. This defines a latent variable interaction. An interaction of a box with a circle or of a circle with a circle. Either way, it's the same. So I have named my new interaction circle mood sex, because it's the interaction of mood and gender. And then I'm letting that new interaction circle predict symptoms, which I know is going to be a contextual effect because of the way everything is set up in this model. And if I'd like the between version, I can add the within-person moderation to the contextual moderation and get the between-person moderation all the same. Go for it.
Just to be clear, this is all on the second stage of the mediation, right? It's all mood to symptoms.
Yep.
And you have that line coming down from sex, hitting the level 2
Mm-hmm.
path, and then also the level 1 path.
Yep, and you're going to have to learn to do this. Yep. That's now I remember why you're so interested, because yeah, you're going to have to figure this out. And so you might ask the question, well, why only that path? Aren't there 3 paths in the story? And the answer, practically speaking, is you can't have 3 latent interactions in the same model with maximum likelihood. Each one increases the dimensions of integration. So this would be a Bayes situation if you wanted to have a lot of latent variable interactions. All right. Somehow I ended up with, yeah, that's really funny. It capitalized my letters, and so it's like BM sexy. Like, that is not what I meant. BPM sex Y is the name of it, because 8 characters is, you have to get creative with your naming conventions. But the new output, let me see what happened here. Yeah, so here is my cross-level interaction. So within person M to Y on women, that is the gender difference and the level 1 relationship between mood and symptoms. So in women, the extent to which you experience greater symptoms when you have relatively greater negative mood is a little bit stronger, it looks like. Where's the original one? X M to Y. Where did it go? I lost it. Oh, there it is. Yep. So it's a positive relationship in men. It is a slightly more positive relationship in women, but not significant. So note the within person M to Y is down here under intercepts now because it's being predicted, whereas the others are still under means because they are not being predicted, not being moderated. That might be a better word in this case. Did I try to do anything else? Not in this model. I know I did at least another model because I've got way too many pages left. So here's some words. I wrote up steps 1 to 3. I would not have kept the last moderation model given that nothing came of it. And then I have an equation that I attempted. So this equation is similar in structure to ones that you've seen. The only difference is that we are predicting multiple outcomes at the same time. So I have a level 1 model for mood. I have a level 1 model for symptoms as outcomes. I decided to stick extra letters as subscripts to keep track of what's for what. Some people make that superscripts, which gets weird because then it can be confused with like exponents. Extra subscripts is another thing. It's up to you how you notate it as long as you're internally consistent. So I have stress TI here in the level 1 model. Uh-oh. You told me that my Zoom got disconnected. Ruh-roh, Raggy. Hang on. Come back, Zoomers. My internet is down for a second.